So let's go ahead and look at the exercises for chapter 5. Let's start with the multiple choice questions. A campus program enrolls half undergrad and half graduate students. If a random sample of 4 students is selected from the program to be interviewed about a new fast food outlet on ground floor of the campus building, what is the probability that all 4 students selected are undergraduate students? So this, your sample, is your n. So n is equal to 4. We are already informed that half are undergrad and half are graduate students. So that means that the probability of success is going to be 0.5. You have n, you have p, that means that you have binomial probability distribution. You're looking for the probability of x, all 4 students selected are undergrad, for x to be equal to 4. So this means binomial PDF n, comma, p, comma, x. This is what you need to calculate. So let's use our graphing calculator. Second vars, binomial PDF, 4, 0.5, 4, close parentheses, enter. So your probability will be 0.0625. So B will be the correct answer. Which of the following about the binomial distribution is not a true statement? The correct answer would be D. The random variable of interest is continuous. This is not a true statement. Now, for problem number 3, multiple choice 3. The quality control manager of Maryland's Cookies is inspecting a batch of chocolate chip cookies. The average number of chocolate chip parts per cookie is 6. The manager is interested in analyzing the probability that any particular cookie being inspected has fewer keyword than 5 chip parts. What type of probability distribution will most likely be used to analyze the number of chocolate chip parts per cookie? Since the only information given to us is the average, lambda, then in this case we would have to use Poisson probability distribution. So this would be B. A company has 125 personal computers. The probability that any one of them will require repair on a given day is 0.025. To find the probability that exactly 20 of the computers will require repair on any given day, one will use what type of probability? We are given n, which is 125. We are given p, which is 0.025. So since n and p are given, this means we would use binomial distribution. And if you were looking to calculate this probability, you would do binomial PDF n, comma, p, comma, x. This is what you would need to do. Let's look at the problems. A certain type of new business succeeds 60% of the time. This means that this is your probability. P is equal to 0.6. Suppose that 3 such businesses open where they do not compete with each other, so it is reasonable to believe that the relative successes would be independent. That means that x is equal to 3. Sorry, n is equal to 3. Not x, n. What is the probability that all 3 businesses will succeed? That means I'm looking for the probability of x to be equal to 3. The only thing I need to do is simply calculate the binomial probability for x equals to 3. How do I know that I have binomial? N and p are given. So you will do binomial PDF n, comma, p, comma, x. So if you were to use your graphing calculator, you go second vars, binomial PDF, right? And we have 3, comma, 0.6, comma, 3, close parentheses, enter. 0.216 will be the probability. 0.216. What is the probability that at least one business will succeed? Keyword, at least. How do I interpret at least? I'm looking for the probability of x to be greater or equal to 1. How does this translate? X greater or equal to 1 means you're looking for the probability of x to be equal to 1 plus probability of x to be equal to 2 plus probability of x equal to 3. Why do I stop at 3? Because n is equal to 3. You can only go up to your sample size. You will do binomial PDF for each one. You will keep n and p the same. The only thing that will be changing will be your x. So this would be, let me just write it down, binomial PDF 3, 0.6, 1 plus binomial PDF 3, 0.6, 2 plus binomial PDF 3, 0.6, 3. You add them all, and once you do your calculations, this will be 0.936. Again, keep in mind that we have binomial probability distribution. The only way to calculate this type of distribution is to basically calculate the probability of each outcome all the way up to the sample size. Now, for the second one, 40% of all registered voters in a national election are female. 40%, that means this is your probability, so P is equal to 0.4. A random sample of 5 voters is selected, N is equal to 5. You automatically know that you have binomial probability distribution since N and P are given. Find the probability that the sample contains 2 female voters. That means I'm looking for the probability of X to be equal to 2. So we will use our graphing calculator, binomial PDF, N, P, X. So if you were to use your graphing calculator, you will go second vars, binomial PDF, 5, 0.4, 2, close parentheses, enter, 0.3456. Or 0.346 if you're rounding to 3 decimals. Find the probability that there are more than 3 females in the sample. Keyword, more than X greater than 3 means that this will be equal to the probability of X equal to 4 plus the probability of X equal to 5. I stop at 5 once again because the sample size is 5. If your sample size was 10, you would have to go all the way to 10. Now, you will do binomial PDF for each one, 5, 0.4, 4 plus binomial PDF 5, 0.4, 5. And the answer will be 0.087. Now, I'm looking for the expected value. The expected value is nothing but your average, right? The expected value of the binomial distribution, the average, E of X is equal to the mu equal to N times p. This is the only thing you need to do to find the average when it comes to binomial probability distribution. What is the n? N is equal to 5. What is the p? 0.4. So your expected value will be 2. Variance, this is your sigma square. This is equal to n times p times q, which means n times p times 1 minus p. This is what q is equal to. We have n to be 5 times 0.4 times 1 minus 0.4, which is 0.6. So this is going to be equal to 1.2. And for the standard deviation, sigma, we simply take the square root of your variance, square root of 1.2, and this is equal to 1.095. Now, for the third problem, this table contains the probability distribution for the number of retransmissions necessary to successfully transmit a 1024K data package through a double satellite media. So basically, you have your x and you have your p of x, the corresponding probability of each outcome. Now, we want to find the expected value, the variance, and the standard deviation. When you have this type of discrete probability distribution, to find the expected value, E of x, or mu in other terms, you will have to take the sum of x times p of x, basically. So that means I need to multiply these two columns in my third column in order, and then add them all up to find the expected value. So 0 times 0.35 is 0, 1 times 0.35 is 0.35, 2 times 0.25 is 0.5, 3 times 0.05 is 0.15. When we add them all, this is 1. So the expected value is equal to 1. To find the variance and the standard deviation, I have to take the square deviation of every entry from the mean and then multiply it with the corresponding probability. So for the first one, we do 0 minus 1. Once again, 1 is the mu, square times 0.35. This is 0.35. This is 0. This is 0.25. 0.2, and then at the end I add them all and I get 0.8. So the variance is sigma squared and is equal to the sum of x minus mu square times p of x, the corresponding probability, and in this case is 0.8. And the standard deviation right here, sigma, square root of your variance, square root of 0.8, which is 0.895. And you're done. Let's look at problem number 4. The number of power outages at a nuclear power plant has a Poisson distribution, so you know you have Poisson distribution with a mean of 6 outages per year. That means that lambda is equal to 6. What is the probability that there will be exactly 3 power outages in a year? So you're looking for the probability of x equal to 3. Since you have Poisson probability distribution, this is going to be equal to Poisson lambda comma x. That means Poisson 6 comma 3. So if you were to use your graphing calculator, second vars, 0.6 Poisson PDF, 6, 3, close parentheses, enter, 0.0892. So, 0.089 for the solution. What is the probability that there will be at least one power outage in a year? At least one power outage means that you're looking for the probability of X to be greater or equal to 1. Now, I want you to pay attention a little bit here, because if, for example, you had binomial, all you would need to do for this kind of probability would simply be probability of X equals to 1 plus probability X equals to 2, all the way up to your sample size. However, when it comes to Poisson probability distribution, you do not have a sample size. You don't know up to what number your X goes. Therefore, because you're only given an average, therefore, you solve this type of probabilities for Poisson probability distribution by taking the 1, which is the sum of all of the probabilities of all possible outcomes, and subtracting whatever probability you do not include in this probability condition. So if you're looking for the probability of X greater or equal to 1, which probability are you leaving out? You're leaving out the probability of X to be equal to 0. So all you need to do is calculate the probability of X to be equal to 0, and you subtract it from 1, and this will be your answer to this probability. So you will do 1 minus Poisson PDF 6, 0. And if you do the calculations, this will be 0.9975. For problem number 5, the local police department must write some tickets per day to keep the department revenues at budgeted levels. Suppose the number of tickets written per day has a mean of 6.4. So once again, the only thing given to you is an average, your lambda. So lambda is equal to 6.4. Find the probability that less than 6 tickets are written on a randomly selected day from this population. So I'm looking for X to be less than 6. Less than 6 means what? Probability of X equals to 0 plus probability of X equals to 1 plus all the way up to probability of X equals to 5. Less than 6, I do not include 6. So you will do binomial PDF for each one, and then you will add them all. Once you do that, the answer will be 0.384. Find the probability that exactly 6 tickets are written on a randomly selected day from this population. So now you're looking for X to be equal to 6. All you need to do is Poisson PDF 6.4, 6. So if we were to use our graphing calculator, second vars, we scroll down to Poisson PDF 6.4, 6, close parentheses, enter, 0.1586. For your answer. And this concludes the exercises for chapter